So we're going to learn about isotopes today. And so the first thing you need to know is the definition of an isotope is that it's the same element with a different number of neutrons, and changing the number of neutrons makes the atom have a different atomic mass. So if you remember, we already learned that the mass number is equal to the protons plus the neutrons. So if I change the number of neutrons, it's also going to change the mass. But we know that it's still the same element because the proton number will not change. When we write isotopes, we can use lots of different symbols, but they all mean the same thing. So for example, I could write lithium dash 8. That means it's a lithium atom with an atomic mass of 8. I could write the same thing as Li-8 and use the symbol of the chemical. I could also put 8 as a little exponent and write Li like that. That's still lithium with a mass of 8. The last symbol that you'll see is lithium 8 like this, but if we add the little 3 underneath it, that refers to the number of protons in an atom. This 3 isn't always written because it comes from the periodic table, and so if it's not there, you can just look it up. The thing I want you to remember about the mass number is it has to be a whole number mass, but it might not always match the periodic table. So for example, if you looked at lithium on the periodic table, the atomic mass is listed as 6.941. But we just saw that lithium could also have a mass of 8. So remember that it's okay if the mass doesn't match what's on the periodic table. All we're doing is adding and subtracting neutrons, but it's still the same element. So we're going to look at some different isotopes of carbon. So for all of these, they're all carbon, which means they all have the same atomic number. So if you look on the periodic table, carbon has an atomic number of 6. Since all of these are carbon, they all have an atomic number of 6. Then you'll remember that atomic number always has to equal the number of protons. So these columns always have to be the same. So as soon as you know the atomic number is 6, then you can also fill out the number of protons. You'll also remember that protons and electrons always have to be equal. So we can also fill out that all of these also have 6 electrons. Because these are isotopes, the differences are in their mass numbers. But you don't have to worry about finding the mass number because it's written right there for you. So if you look at the first example that says carbon 11, this 11 gives you the mass number. This next example, carbon 12, it's written a little bit differently, but the 12 is still there. And so that's your mass number. The next example has a 13. Again, that 13 is the mass number written there for you. And the last example, the 14 is here. That's your mass number. Now you'll remember to find neutrons, we have to do the mass, minus the number of protons. So in my first example for carbon 11, I have 11 as my mass, minus the 6 protons, and so in this example there are only 5 neutrons. But in carbon 12, because it has a different mass, that came from the neutron number being different. So here I start with my mass of 12 minus the 6 protons that you still have, and now my example has 6 neutrons. They're still both carbons because the protons are the same, but we've changed the number of neutrons, which makes them isotopes. Carbon 13, I subtract the 13 minus the 6 protons, and this example has 7 neutrons. In my last example for carbon 14, I take 14, which is the mass number, minus the 6 protons, and this time I have 8 neutrons. Now, all of these examples are isotopes because they're all carbon, because they all have the same number of protons. But the big difference between them is that we changed their neutron number, which changes their atomic mass. So what I want you to do is see if you can do the table on the bottom that's underneath this, and then we'll compare our answers together next class.